Hello everyone. Today I'll explain you the question number 5 of second internal. It is how Simpson's rule, one of the most popular numerical integration techniques, can be derived using the Newton's Cotes formula. So Cotes formula, it is a family of formulas based on polynomial interpolation. So Newton Cotes formula approximate integrals by interpolating the integrand with the polynomial, and they choose equally spaced nodes in the interval of integration, and examples include the trapezoidal rule, Simpson's rule, and others. So our goal is to approximate the integral by constructing a quadratic polynomial that interpolates f of x at the points x0, x1 and x2 with equally spaced nodes. So we set h is equals to b minus a by 2, so that our interval a comma b is divided into two equal subintervals. So we use the Lagrange form of interpolating polynomial. So here p of x is the quadratic polynomial that exactly matches the function at the three chosen points. So the Lagrange basis polynomial L0x, L1x and L2x, this ensures that the x is equals to xi, Lix is equals to 1 and the others are 0. So after that, we see that integrating the interpolating polynomial, we replace the original integral with the integral of the interpolating polynomial. So the key step is to compute the integrals of the Lagrange basis functions over the interval a comma b. Then after that we'll see how to evaluate the basis integrals. So due to symmetry of the Lagrange polynomial for three equally spaced points, the integrals for L0 and L2 yield the same coefficient, while L1 is weighted 4 times as much. So this is precisely the essence of Simpson's rule. So now we'll see the Simpson's rule summary. As we have derived Simpson's rule, it gives us a very effective formula for approximating the definite integral when the function is reasonably smooth over the interval. So it is derived directly from integrating the quadratic interpolant obtained via the Newton Cotes framework. Now we'll see that while Simpson's rule is quite powerful, especially when the underlying function is smooth, so it does have its constraints. And when functions are complex or irregular, more advanced or adaptive methods should might be necessary. So today we have seen a clear derivation of Simpson's rule from Newton's Cotes formula. So where we have seen the steps like starting with the Newton's Cotes framework, then after selecting three equally spaced nodes and then building the quadratic Lagrange interpolant and then integrate the basis polynomials, and after that lastly arriving at Simpson's rule. Thank you.